In today's demo, we are going to look at how platform team can make use of GitOps to deploy and manage OpenShift clusters across multi-hybrid cloud environments. Over here, we have the central management plane that comprises of different tools and platforms. For instance, the Red Hat Advanced Cluster Management for Kubernetes, RHACM, is in charge of governance and policies management, as well as observability. What can happen over here is to leverage on ACM capabilities to govern policies, as well as to ensure that there is no configuration drift and that the cluster is in full compliance with the required policies. When it comes to the Red Hat Advanced Cluster Security for Kubernetes, or ACS, we will be able to ensure that the clusters itself is secure from day zero and apply the shift left concept when it comes to DevSecOps. As for the Ansible Automation Platform, we are going to leverage on the workflow capabilities to go and deploy and onboard OCP clusters onto ACM as well as ACS. We have the Red Hat Quay, which is the Enterprise Container Registry for storing container images. In our case, over here, we are using Elastic as the SIEM. This can be different across different organizations. For instance, you can be using things like Splunk instead of Elastic, but it really doesn't matter. So what's going on over here is that we have a central clusters where all logs from the managed clusters are being forwarded to. And we are using the Red Hat single sign-on as our identity provider. And it is also deployed on the central clusters as seen over here. The OAuth across the managed clusters will be configured in such a way that it points towards the RHSSO that resides within the central clusters. So all managed clusters will then be able to be managed by the Red Hat Advanced Cluster Management and ensure that all the governance policies are enforced on all these managed clusters. So from a platform team perspective, we will be setting up things like namespaces and network policies, limit quotas for the developers to be able to use them when they deploy the application. And all these are going to be backed by Argo CD on the individual managed clusters. In this demo itself, we are really leveraging on AWS as the underlying platform, but it really doesn't has to be AWS. OpenShift can be run and operated on different public clouds like Azure, IBM Cloud, Google Cloud, for instance. And that you can also run on-prem, for instance, on VMware and on Nutanix. In this demo, we are going to just focus on AWS, but really there isn't any limitations when it comes to that. We are going to use Ansible to deploy the OpenShift clusters on AWS. Right? We will leverage on playbooks and orchestration flow. And once the cluster is being deployed, what will happen is that Ansible playbooks will onboard the newly provisioned OpenShift clusters onto ACM, and that things like the IDP configurations will be configured. We will be setting up compliance operator, namely coming from the CIS perspective. We will ensure that the compliance operator will run the CIS hardening specs and requirements on the workers and masters nodes. And then we have the NTP configurations that we will also be configuring, the cronyconf that we will set it up using machine config. Then we will ensure that all the logs are being forwarded to Elasticsearch and that they get indexed and that we will be able to see the logs from Kibana dashboard. We will also be setting up Argo CD, or in our case, the OpenShift GitOps operator on all the managed clusters so that we will be able to enforce policies on all those clusters. And we will be ensuring that the newly created clusters will be onboarded to the ACS as well to make sure that security aspects of the clusters are being taken care of. And when it comes to day 2 onboarding, we will also be making use of the GitOps capabilities to perform actions such as namespace creation, network policies creation, resource quota creations, limit ranges creation. All these things will be done from a GitOps perspective and in an automated fashion to ensure that there is no drift in configurations. So this is the Ansible Automation Platform. It is running as a virtual machine in Amazon Web Service. We have already 2 clusters that has been pre-built for this demo. We have the Ansible Automation Platform virtual machine as well as the jump host running in AP Southeast 1 region, which is in Singapore. Alongside with one of the clusters, we also have another cluster that is running in AP Southeast 2, which is the second region, right? Then over here, we have the US East 1 region, which is where we are going to deploy the new OCP cluster. Right now, there is nothing in it. So Ansible is going to deploy the OCP cluster in this region and also onboard them onto the Red Hat Advanced Cluster Management as well as the Advanced Cluster Security. So if you were to go and look at what we have over here in the dashboard, we really will just be running this workflow template that will provision the whole environment. So if you look at it, the first thing that we do is to deploy the cluster, and then we'll import them into ACS and RHACM. Let's just kick off this deployment. So if you look at it, the things that we will do is to define the region, the cluster name, instance types, how many masters, worker nodes, the domain, install directory on the jump host, and ACS information, and all the other stuff that will be mentioned inside. So let's just hit launch. So what it does next is that it's just going to start deploying the cluster itself. So you can see that it's generating the install config, and after which it's just going to do the actual deployment. So it's deploying the cluster at this moment in time. We will come back to this cluster later on. If we were to go back to the hub cluster, we can see that the hub cluster itself is where the RHACM, ACS, the SIEM, for instance, in our case, the Elasticsearch operator is being installed. So over here, the Keycloak Red Hat single sign-on is also being deployed as an operator. So if you were to look at the list of operator being installed, you can see over here that we actually have this set up. And if you look at the client itself, we also have the cluster 1 and 2 client being set up using the SSO operator that's running on top of the OCP hub cluster. If we were to go in, once you log in, you can see over here that we have a realm, the OCP realm for this particular demo. Within the realm itself, we have the 2 clients that is being automated and created by Ansible. And then we have the user. In this case, the user is OCP user-1, right? So this is the user that we have defined over here that can be used to log into the cluster, right? If we go through SSO. So going in, you can see that these are the configurations. And again, all these things are going to be automatically configured. So that is what is going on. If you were to look at the Elasticsearch, Elasticsearch has been deployed. You can see that this is where the Elasticsearch is running on the hub itself, and it's running 7.12.0. And this is where the Kibana dashboard is. You can see over here that these are all the logs that's coming in from various clusters. For instance, what are the clusters that has been forwarding the logs to the main cluster? From here, you can see that the hub itself is forwarding the logs to the Elasticsearch operator that's running, right? And then we have the 2 managed clusters over here that's forwarding the logs as well. So you can see the distribution of the logs that's being sent over. From the cluster perspective, again, if you look at the Elasticsearch operator, we actually have set up the Elasticsearch cluster over here. We have Kibana also being configured over here as well. So those things are all being set up, and we have different pods that's running in this case. So this is kind of what we have for Elasticsearch for RHSSO. We can see over here that there is a total of 3 clusters. We can see the compliance of all the different clusters over here. It shows, for instance, things like the CIS compliance for the various clusters itself. Then we can also see what are the top risk deployments that is being made available within this environment. It shows things like, what are the suspicious process execution, what are some of the image vulnerabilities that has been found. And over here, we can see that the 3 clusters, including the hub clusters, being monitored by ACS. Integration-wise, it is able to integrate with a wide number of different image registries, container registries, things like Slack, PagerDuty, and backup integrations with things like Amazon S3. If you look at this, the init bundle for each of the clusters is also being created by Ansible, right? So all those things are being automated. The next one that we go to is the advanced cluster management. So over here, we have the dashboard where we can see that there is a total of 3 clusters that is currently being managed by ACM. Drilling down, we can see that there are all these various clusters with labels. In this case, cluster 1 and 2 has environment set to dev and the local cluster itself. So the managed cluster is running on 4.9.26. ACM Hub itself is running on 4.10 OCP. We can very easily do things like upgrade on the cluster, right? So you can do, for instance, select the latest version, and if you just hit the upgrade button, it's just going to perform an upgrade on the target itself. So after which, we can see the applications. So over here, for instance, on the first and second clusters, we have set up infrastructure requirements. So looking at the second cluster, for instance, you have all the various limit ranges that's being set. So this is where the second cluster is, and this is where the Argo CD instance of the second cluster is located. You can see that it's all the same, right? So whatever that has been defined has been deployed, and it can be seen directly from ACM UI as well. So you have a single pane of glass for viewing everything. And governance-wise, it is able to make use of GitOps to enforce the various policies on the target machine. For instance, you can see that we have set up the infrastructure requirements. We have set up the logging operator to make sure that we are able to forward the logs to the central Elasticsearch cluster. We have set up RHSSO for doing single sign-on. We have the compliance operator that we set up all the managed OCP classes. We ensure that we run a CIS scan and enforcement on all these managed clusters. We ensure that GitOps, Argo CD is being installed, right? We also make sure that things like NTP settings are being set up properly on all the masters and workers. So clicking on it, you can see, for instance, in this case, it shows what are the clusters that are compliant, right, with all this, and what are the things and the template that was being used, right, in this case. So one of the other things besides logging will be metering. So we can see that we are able to use Thanos and S3 bucket in this case to ensure that all the matrix from all the various clusters are being captured, and you have Grafana as a single pane of glass to go and look at all the performance of the various clusters that's being managed by ACM. And of course, if you look at this over here, you know, what's going on is that you can also use your own custom matrix and do your own visualization, right? So it's very neat where you can see everything from one place. So then, more importantly, right, how are all these governance and policies being written? We actually define them in the Git repository. So you can see over here that I have a Git repo that comprises of the various things that we want the ACM to enforce on the managed target and clusters. For instance, in this case, we ensure that the compliance operator is being installed on the managed environment. One of those things that we do is to ensure that namespace is being created, and after which we make sure that the operator group is also being done, subscriptions, and all these things are actually being enforced on the target, all using the custom resource definition that comes along with the Red Hat Advanced Cluster Management. We do the policy under the Open Cluster Management, and then we will apply this on the target. You ensure that all this operator is being properly defined and installed. We will ensure that it is in the succeeded phase to know that everything has been properly set up without any issue. And using the placement rule, we are able to define which cluster we want these to be enforced on. So we can see over here that we are basically setting up all this compliance operator using the key value pair where environment equals to dev. If you recall what we saw earlier from ACM, you know that these are actually going to be enforced on the two existing OpenShift clusters that we have already set up in the AP Southeast 1 and 2 region. So this is just the first policy, after which we will be able to do things like config management as well. So if you look at it, the CIS policy, we want to make sure that the OCP CIS node and CIS profile is all being deployed and enforced on the managed target. Then things like the scan settings, we want to say default auto apply so that it will proceed to enforce the policy on the managed node and clusters. So you can see that the remediation action over here, we have set it to enforce rather than inform. If you don't want to enforce immediately, you can actually set it to inform so that it shows up as an alert and warning on the ACM dashboard rather than proceeding to enforce everything directly on the target itself. So you can see over here that these are the stuff that will be performed by the compliance operator. And again, it is going to be in the dev environment. So if we were to go back to the cluster where it has been enforced, in this case, on the second cluster, we can see under the list of install operator, there is a compliance operator that has been deployed. Clicking on it, we can see things like the results, check results, the remediation that was enforced. We do the scanning is in the done phase. So the scanning was done, the remediation was also performed. Things like which compliance suite we have, the profile bundle, the profile itself. So various things that was actually being enforced by the GitOps approach on the managed cluster. So looking at the ACS as what we saw earlier, it actually has a single pane of glass as well to show you what are the compliance that has been achieved across the various cluster. Right. So over here, we can see that overall compliance level is 92% across the various environment. And it shows you all the controls, which most of it is actually at 100%. We just only have some of which not actually being enforced. But we all know that there will always be certain things which is up to the user to define, and hence it is actually not 100% compliance that can be achieved out of the box by this compliance operator, right? So for instance, let's say you have a specific network policies that you want to define for your namespace and those things and some other factors, then those are the stuff that will need to be manually done by the operations team being defined, and so that we can achieve that 100% compliance. But regardless, it actually gives you a very good baseline to start with, right? Being more than 90% compliant at day one build is not too bad. So those are the stuff that, the compliance operator is able to do out of the box. I mean, of course, we can also do things like the NIST standards, which is also very popular. Things like PCI DSS for the payment card industry, things like the HIPAA compliance, right? Various stuff that can actually be enforced across the various clusters just by using GitOps and ACM, etc. Right? So let's just go back to the definition again. So what are the other stuff that we are doing over here? We are also setting up the OAuth configuration. So you can see in this case that we have updated the OAuth of the managed cluster to include HT password, as well as to make sure that we can do OpenID pointing towards our key cloak. So one of those things that you may notice over here is this client ID. So we can get the ACM to auto-render the name. In this case, the client ID will correspond to the name of the managed clusters that we are going to manage. It will automatically generate the required client ID based on the name of the cluster, which makes it very convenient. You don't have to go and manually figure out what to fill in, because this is the same template across different clusters, and you don't want to have to create different ones for different stuff. Over here, you can see that we are all pointing towards the RHSSO that is running in the ACM hub, we are going to the OCP realm in this case. So all this information is all being configured and enforced by Git itself, right? So let's say if you want to just log in as the cluster itself, you can see that there are the different providers that has been created. So HG password and keycloak was what was enforced by GitOps. So let's say if we go with keycloak, we saw that just now there was an OCP1 user. We just have to log in using the OCP1 user. And you can actually be able to perform other works in this environment just using this user. So it does work, right? Everything is being properly enforced and configured in this case. All right. Beyond the compliance operator, we also set up the NTP configurations, in this case for both the master and worker nodes. So over here, we see that we actually add a machine config inside here. We call it 50-master-crony, and this is actually the content that we are passing in. So this will be the NTP configurations that we will be enforcing on the target. So if we were to look at the actual configuration itself, you can see that this is the configurations that we want to pass into the target node. So if we were to just go into any one of the node, so let's say in this case, we were to go into the master node. You can see that this is exactly the same as what is being seen from the base 64 string that we have just decoded. So all these things are being dropped into the respective worker and master node to ensure that the NTP configurations are being set up properly. So looking at machine configs, you can see that it is properly defined over here as well, right? So that all these changes will get propagated to the managed clusters, all right? So other than this, we have the infrastructure requirements, which was very similar to what we saw earlier. Basically, what's going on in this case is that we have it pointing to another Git repository that belongs to me, which really talks about for Argo CD demo, we have this multi-cluster customized sample demo, right? Again, we are leveraging on the templating capabilities of ACM to go and ensure that we are passing in parameters and requirements based on the cluster itself and not just just enforcing the same thing everywhere, right? So we need that flexibility, and it can actually be achieved quite easily by using things like customize that we see over here. So we have a base and an overlay. What can be defined in the base could be things like ensuring that we do an implicit deny for all ingress requirements when we do a network segmentation. So we have implicit deny. We can also do things like ensuring that the persistent volume claims is being set to 0 for stateful application that has databases. We want to make sure that perhaps only the namespace where the database is running is able to request for PVCs. So everywhere else should be 0. Those things can then be overlaid using customize. So if you were to look at it as what we were talking about for the database, we can actually set a PVC of 10 so that it is able to get PVCs. And in this case, if you were to look at the front end, when it comes to the network policies, we want to allow traffic to go to the front end port itself. So all these things will then be allowed through for a very specific namespace that is holding and running certain services. And then in the case of the database, we can see that the database that we have in this particular cluster, cluster 2, is actually a MongoDB, and hence the network policy that's needed will be for port 27017. If it is another kind of database, we want to ensure that the network policies is set appropriately. Things like port selector as well as namespace selector, those things will then be overlaid properly. For instance, in the case of OCP cluster 1, we know that this is actually running a Postgres database, right? So hence, the traffic will be going towards 5432 instead. Right, so we have great flexibility in terms of how we want to define all these parameters and values for all the various classes. We have full control over all these configurations from day one. So it will help the developers, for instance, to be able to consume the service and the namespaces accordingly. If you just go into, for instance, this particular cluster one, just look at the various resource quota, you can see over here that all the resource quotas and limits are being set appropriately. And the network policies are also being done appropriately. So for instance, in this case, we can see these are the stuff that is being done. And better example will probably be here because this is an actual application, right? So you can see over here that the ingress policies will need to match certain deployment and rules before the traffic is allowed through. Right, so there's a lot of things that we can actually do when it comes to using ACM to enforce the configurations across the cluster. So in this GitOps operator, it really just is to ensure that the Argo CD gets deployed on each of the managed clusters. Argo CD is a very popular tool these days, being used in continuous deployment and delivery. So it just enforces to make sure that it is actually being set up across the managed clusters. And over here, this is the logging operator. So what happens is that we want to ensure that the OpenShift logging namespace gets created. We want to deploy the operator for doing cluster logging and making sure that everything is being set up. In this case, the managed clusters will need to ensure that FluentD is collecting the relevant logs and information from the clusters, and then we do a forwarding itself. So you can see that we are really forwarding to the remote Elasticsearch clusters that's running on the ACM hub, and what are the stuff that we forward will be the infrastructure logs. We can, of course, also forward other logs like application logs. It's just that for demo purpose, we are doing infrastructure log over here. Then when it comes to cluster labeling, we want to make sure that all these logs that comes from various clusters are being properly labeled. So in this case, we are saying that the cluster key will take on the name of the cluster itself, which is why you're able to see over here that there's a label for all these different clusters, right? And it actually shows you a much clearer picture on where the logs are actually coming from, right? So it's also going to the dev clusters in this case, right? So basically, if you look at all this, it really very nicely defined the requirements when it comes to onboarding the new managed cluster itself. So everything can be done directly from ACM. There is no need to do any manual deployment or configurations, and ACM will ensure that there is no configuration drift. If there is any, it will show over here. So the only stuff that you see is this CIS scan, which we have explained earlier on why there is a violation that's being seen. Right? But of course, this can be fixed by having discussions with the security team on what are the stuff that is needed. Right? So it will just show all these things in this case. Let's just go back to the other cluster that we are deploying and check the deployment. So the cluster is still being deployed. If we were to go back to here, the US East 1 region, we do a refresh. You can see that almost all the nodes are being deployed and it's almost up. So let's just wait for it to complete. Okay, the cluster has been deployed. The client has been created on SSO. We are able to proceed to the next step. What happens after this is that it is going to continue to import into ACS, right? So we can see that it is at this point in time waiting for the ACS operator to be deployed while running through all the steps that's needed to get everything up and running. So we can go back to the other screen where we have ACS. You can see over here that it is still waiting for everything to come up. So let's just wait for a while for all the stuff to be ready. Okay, it's done. Let's just go and check. The last piece of the workflow is really to go and import the cluster into the Red Hat Advanced Cluster Management. So you will go through all the steps required to generate the relevant settings and then import the cluster into ACM. So if you were to go and check the advanced cluster security, you will see that it is showing 4 clusters now. You look at it, the 4th cluster is actually OCP cluster 3. It has been onboarded, integration wise. Ansible has helped to set up the init bundle as well. Now you can actually just get this if you do a scan environment. Now it shows 4 clusters, right? So all this information pertaining to all these clusters is going to be shown over here. And pretty much we can use this to track all the clusters that have been imported, right? So going to Advanced Cluster Management, you can see as well that now we have this cluster being imported. So this is really the 3rd cluster. So if you recall earlier, we did start the upgrade for this first cluster and it's now at 27%. So it's able to do everything pretty much from this dashboard itself. Everything can be done. We just have to wait for a while before it shows the infrastructure provider as well as the distribution version for this particular clusters and the number of nodes that we have for this cluster. So we can just wait for the cluster to be fully imported from the Ansible workflow itself. So everything has been completed from Ansible perspective. We can see that the workflow has been successful. Everything is done very nicely. Let's just go back to the cluster. From ACM UI, we can see that it has been fully imported as well. This thing has progressed to 77% completion. If we were to go and look at the governance, well, now we can see that there are a total of 3 clusters now as opposed to 2. So this new cluster that has been created has also been onboarded onto ACM. And right now it is being enforced with all the different policies that we have defined to be the desired state that we want it to be in. So we can see that right now it's actually doing things like the logging operator. And then after that, over here, we still have the compliance operator. The same thing can be seen from the application perspective. So this actually is the infrastructure requirements for the 3rd cluster. Pretty much, it is a bit similar to what we see for the other 2 clusters with all the relevant network policies being defined for the specific application for this cluster. So going back to governance, we can see that everything has actually been enforced throughout the clusters and things are looking good. So yeah, you can see over here that we have indeed been able to make use of automation and GitOps methodology to ensure that all the new clusters that have been created and onboarded are in conformance to the requirements and settings and information and all those stuff that we wanted the clusters to be adhering to. Thank you very much for watching. I hope you have learned something from it. Thank you.